Okay, so for this video, we will uh, solve for the derivative of functions using the property of derivative of a product. So let us recall that the derivative of a product, so if say for example we have a product of u and v, so the derivative of the product of u and v is equal to u multiplied by the derivative of v with respect to x plus v multiplied by the derivative of u with respect to x. Okay, so it's like first factor multiplied by the derivative of the second factor plus the second factor multiplied by the derivative of the first factor. Okay, so let's apply that on some examples. So find dx over dt. So that is the derivative of x with respect to t if we are given that x is equal to t squared times 3t squared minus t plus 4. Okay, so actually we have we can find its derivative using two methods. So the first is the simplest for this, for this problem is it's very simple if we will just distribute t squared for each of the terms and then deriving each term. The second one is using the product rule. Okay, so for this problem we will be using both, and then we will compare the two answers. Okay, so solution 1, we will be using the distributive property. So first solution, so we have x is equal to t squared times 3 t squared minus t plus 4. Okay, so applying the distributive property, so we will distribute t squared. So x is equal to, so t squared times 3t squared, so that is 3t, and then add the exponent, so 2 plus 2 is 4, minus t squared times negative t, so that is t cubed, and then t squared times 4, so that is plus 4t squared. Okay, and then deriving, so the derivative of x with respect to t is equal to the derivative of this, the derivative with respect to t of 3t to the power of 4 minus t cubed plus 4t squared. Okay, so although our variable of integration is t, so we can still apply the previous formula, so for the previous formula that we had was powers of x, but actually it could be any variable, so the derivative with respect to x of x raised to n is equal to n x raised to n minus 1. Okay, so actually the variable x could be any variable. In this case, we are deriving with respect to t, then the derivative with respect to t of t raised to n is equal to n t raised to n minus 1. Okay, so it doesn't matter what variable is it. Okay, so therefore we can still apply the derivative of powers. Okay, so by distributive property, so let's integrate each term. Let's differentiate each term, sorry. So we have, this will become a derivative with respect to t of 3t to the power of 4 plus derivative with respect to t of negative t cubed plus derivative with respect to t of 4t squared. Okay, so what's next is the constants, so we can take out the constants. So here we have 3, here we have negative 1, here we have positive 4. So 3 multiplied by the derivative with respect to t of t to the power of 4 that is minus, so minus 1, so d over dt of t cube, okay, plus 4 times d over dt of t squared. Okay, so this will become, so 3 multiplied by the derivative of t to the power of 4, so using this formula, so it will become n is 4 t raised to 4 minus 1 minus derivative of this is we have 3 t raised to 3 minus 1 plus 4 derivative of t squared with respect to t is 2 t raised to 2 minus 1. Okay, and then simplifying, so 3 times 4, that's 12 t cube minus, so we have here 3 t squared plus 8 t. Okay, so that is dx over dt. Okay, so that is our first solution. So the second solution is by applying the derivative of a product. Okay, so let's rewrite the problem. So x is equal to, we have there t squared times 3t squared minus t plus 4. Okay, so let's apply the derivative of a product. So in this case, our u here is t squared, right? And then our v is this, no? The whole second, all the terms inside the parenthesis. So all of those are our v. No? So in product rule, so the derivative of x with respect to t is equal to the derivative with respect to t of, so let's use the bracket since we know that we have parentheses inside. So t squared times 3t squared minus t plus 4. Okay, so again, this is our u and then this is our v. Okay, so in the product rule, so the first factor multiplied by the derivative of the second, so we will have t squared multiplied by the derivative with respect to t of the second term, which is this, so 3t squared minus t plus 4, okay, plus the second term, 3t squared minus t plus 4 multiplied by the derivative of the other one with respect to t. Okay, so like that. Okay, so now let's derive. So we have here t squared multiplied by, so distributing, no? So distributing, and since we are already very good with differentiation, so let's differentiate it directly. Okay, so without distributing the d over dt anymore. So but we know that we have to take out the, so for the first term, so we have 3t squared, so we have to take out the constant, so that is 3 multiplied by the derivative of t squared. So derivative of t squared, that would be 2t raised to 2 minus 1, so that is 2t. Okay, minus, so the derivative of t with respect to t, now that will become dt over dt, so that is equal to 1. And then plus derivative of 4, so 4 is a constant, so derivative of a constant is 0. Okay, so plus, copy this, So 3t squared minus t plus 4 multiplied by the derivative of t squared, so that is 2t. Okay? So therefore, let me get another sheet of paper. So therefore, this will become t squared. So multiplying this will become 6t minus 1. Okay, plus we can distribute 2t here. So 2t times 3t squared, so that is 6t cubed, right? And then 2t times negative 2t, that is minus 2t squared. And then plus, so 2t times 4, that is 8t. Okay, and then distribute this. So this will become 6t cubed minus t squared times negative 1, so minus t squared, plus copy this, 6t cubed minus 2t squared plus 8t. And then simplify. So our dx over dt is, so 6 plus 6, that is, we have 12 t cubed minus negative 1 minus 2, so minus 3t squared plus 8t. Okay, so comparing with our previous example, so our previous answer was this. Okay, so we arrived with the same derivative. No? So this one for our first answer, and then this one for the second. Okay, so they are the same. No, obviously we would expect that they have the same derivative. Okay, so but as you can see for this problem, I think solution number 1 was easier, right? So it actually depends upon the problem. If we have more complicated functions to differentiate, no, so sometimes distributing may be already impractical, no, so it's impractical, or it could be impossible, no, impossible to no, to distribute, or it could be very difficult to distribute, very impractical. So especially if, say for example, we have, so this is easier because the exponent of the function here is 1, no, just 1. So what if this is squared, no, or cubed, or to the power of 4? So it, expanding this term would be much more difficult, no. So that's why we still need to know how to apply the product rule. Okay, okay, so for our next example, so find dy over dv for y is equal to, we have the quantity of v squared plus 3 multiplied by the quantity of v squared minus v plus 1. Okay, so for this problem, so obviously we will be using the derivative of a product. Okay, but we also have an alternative solution again, so we can distribute, no? So we can distribute v squared and 3, no, with v squared minus 1 and minus v and 1, no, but it will be what you call this, the process will be still long, no, relatively. So but if we apply directly the derivative of a product, then we will avoid expanding, no, this term. So using the derivative of a product, so this is our u, and then this is our v, no, from the formula. So the derivative of y with respect to v is equal to the derivative with respect to v of, so let's use a bracket because we know that we already have a parenthesis here. So v squared plus 3 times v squared minus v plus 1. Okay? So in the product rule, so first term multiplied by the derivative of the second term plus the second term multiplied by the derivative of the first term. So copy the first factor, v squared plus 3 multiplied by the derivative of the second factor. So d over dv of v squared minus v plus 1. Okay? So plus the second term, copy v squared minus v plus 1 multiplied by the derivative of the first term. So d over dv of v squared plus 3. Okay? So, copy the first term and then derive the second term. So, v squared plus 3 multiplied by, so derive each term. So, derivative of v squared, so this will follow the power formula. So, 2v raised to 2 minus 1. So, we will have 2v. Okay? Minus the derivative of v with respect to v, that is equal to 1. Then, derivative of a constant is 0. Okay? Plus, copy, v squared minus v plus 1. The derivative of v squared plus 3 is, so derivative of v squared, so same here, so that is 2v. Plus, derivative of a constant, so we have 0. Okay, so let's simplify. So we have v squared plus 3 times 2v minus 1 plus v squared minus v plus 1 times 2v. So it's up to you if you want to, what do you call this, expand that. But I think the factored form is okay for me, acceptable. So v squared plus 3 times 2v minus 1 plus, so write this first, 2v times v squared minus v plus 1. Okay, so that answer is already acceptable. Now, but if you want to expand, so let's expand. So v squared times 2v, that is 2v cubed. So v squared times negative 1, so minus v squared. 3 times 2v, so that's plus 6v. 3 times negative 1, that is negative 3. Then plus, distributing this, so 2v times v squared, so that is 2v cubed minus 2v times v, so minus 2v squared, and then plus 2v times 1, so that's 2v. So simplifying, so 2v cubed plus 2v cubed, so that's 4v cubed minus negative 1 minus 2, so minus 3v squared. 6v plus 2v, so that's plus 8v. And then minus 3. So that is dy over dx. Okay? So let's check if we expand this. So let's check if it's equal to this. So expanding, so I'm going to rewrite it. So we have y is equal to, we have v squared plus 3 times v squared minus v plus 1. Now, so expanding, distributing v squared, so that is v to the 4th. V squared times negative v, so minus v cubed. V squared times 1, so plus v squared. And then 3 times v squared, so that's plus 3v squared. 3 times negative 1, negative v, so that's minus 3v. And then 3 times 1, so that is plus 3. So y is equal to, we have v to the 4th minus v cubed plus 1 plus 3, so that is 4v squared minus 3v plus 3. Okay, so deriving, so dy over dv is the derivative of this. So derive v to the fourth with respect to v, so that is power formula. So write 4 v raised to 4 minus 1, so that is 3 minus, so we have here 3, so write 3 v raised to 3 minus 1, so minus 3v squared, plus 4 times derivative of v squared is, okay, so that's 4 times derivative of v squared, so 2v, no, minus 3 times the derivative of v with respect to v, that is 1, plus derivative of v constant is 0. So dy over dv is equal to 4v cubed minus 3v squared plus, this is 8v minus 3. Okay, so we have the same derivative. Okay, so as I've said, so even if we have a solution, no, that is can have an alternate solution, not just by distributing, but again, when in our further lessons, when the functions get more complicated, so it will be very impractical for us to distribute, no? So for this example, so since we are starting with easy problems, then the expansion is manageable, so it can be easily done, no? So but when we have more complex problem, then it's very difficult for you to expand, no? So we have to resort to the derivative, the use of the derivative of a product property. Okay, so that's it for this video, and thank you for your time.